Hey guys, what's up? Eddie Alho here with KissAnalog.com. Today is exciting because I'm going to start a new series. I don't know how many videos it'll take me, but I'm going to test this audio amplifier. It's a 230 watt by 230 watt power amplifier, Class D. They call it a Class T, as in Tom. That is supposed to be the new and improved Class D. Well, it's not so new anymore, but anyway, this is a TA 2022 BTL 2.0. Got it on sale at Parts Express, and takes a AC input, but I'm going to show you how we can power it up with the DC power supply, because I don't want to build up my power supply right now. I'm kind of anxious to power this thing up, so as a first check, I'm going to power it up with the DC power supply. I'm going to show you how to do that. I've seen some comments on the web before, people asking if that's possible, and it is. So let's do it. We're going to do a first check out of this thing and watch some LEDs go on, and we'll see how far we get today. Alright, thanks. Alright, so I did not gain paperwork with this power amplifier board. This is an audio power amplifier capable of 230 watts by 230 watts. It's the TA 2022 BTL 2.0. Now the TA 2022 came from this tri-path part, the same part number. This is a Class T, as in Tom, an improved version of a Class D. That was a patented thing by tri-path. A few good audio manufacturers adopted that and used it in some of their products. I think Apple was one. Not saying they're the best audio guys, I'm just saying that they were one of the big companies. So they did have some big companies use their patent and use their modules. Each one of these modules has 2 channels, and in this configuration it's bridged to give out 230 watts. This guy seemed impressive, and it was on Parts Express on sale for a good price. I'm going to list that right here. I don't remember what it was right now. It looked really interesting to me, and I thought, what the heck, let's get this thing powered up and play with it. Alright, well, you can tell from just looking at it that there's two caps. This is the input power supply, the bridge rectifier, and here's big old poly WEMA capacitor. Nice capacitors, by the way. I'll show you a close-up of this in a moment here, but basically what I just want to point out is you see the 2 potentiometers here, the 2 potentiometers there. So this circuit and this circuit look to be identical to me, with the exception on this side of the board we have the input. This is the input power that splits and goes to both sections. The audio input for the right side, it says R here for right and L here for left, I guess. So the input for the audio is here, the input for the power is here. I put these big old copper pieces of wire here just to make it easy to grab onto with the scope and with the power leads and so on. And this is the output and the other output. So this is say the right channel and the left channel. The difference being this input connector is common to both, and then there's this circuit right here that's common to both. Now both channels have a red and green LED, which kind of hard to tell what those LEDs do. This one says red and this one says POL or POW maybe. So power, and I'm not sure what that means. But and then this LED has no silk screen on it. I mean name. There is a little circle around it, but yeah, I don't know what this circuit is. Maybe it's, there are these 2 relays here, so maybe it's part of the protection circuit and gives some indication that there's an error, there's some kind of problem. Don't know. We'll have to find out. What I want to do is I want to power this thing up, but I don't want to right now build up my power supply with the transformer. I don't know if you can see that. So, and I'm not sure if this is the right transformer. This says 22 and 22 volts, and this guy is 22 and 22. So this looks to be the right transformer. I don't know if it's the right size exactly. It's 160 VA, so it's kind of undersized for this amplifier. Here, let me show you a close-up of this thing. I'm going to show you the naming convention down here. Let's see if we can zoom in on that. I hope you can read this. It shows a minus symbol and then AC, AC, and a plus. So we can see the bridge rectifier. You know, this one's going to be the same way. And on this bridge rectifier, there's a little chamfer here in the corner. And also another thing, when we flip the board over, we'll be able to kind of spot something here. There's a larger gap between this pin and the other three. The other three look like the gaps, you know, are equivalent between those two, and then here it's a wider gap. So when we flip it over, we'll look for that. Now while we're here, I don't know this capacitor company. They look a little fancy. It says LA, Nover, or Nover, I guess. And then LA underneath that, audio grade power capacitor. And then it says 10,000 microfarads, 50 volts. And it's 85 degrees C rated. And then it says negative black. So what I'm assuming is underneath this capacitor, the negative lead has a black marking, so you can tell which one's negative. And then here's those WEMA capacitors I talked about. I mentioned here that it's a 2.2 250 volt. So that's probably on the output of the rectifier for some filtering. Oh, here, let me show you the output here. It says L minus L plus, and over here it says R minus R plus, if you can see that. It says speaker out, and you can see what I mean by the naming convention on these LEDs. I'm not sure how they operate. We'll figure that out, I guess. We can see these poly caps down here. Looks like some metal film resistors, through-hole resistors. Looks like maybe another poly capacitor there. And the name of that part, I don't know if you can see that for yourself. I'll have to, it's hard for me to make it out right now. Maybe you can see it in the camera. But okay, well, these capacitors here have kind of a gold stripe. I know that some vendors use that for their better grade capacitors. It's hard for me to see the name of these capacitors. Yeah, it's really hard to see the names. Maybe you can see them. I'll get my face a little closer so I can try to read the names of those. So what else do we see? Ferrite, looks like ferrite beads down here on the board. High frequency filtering. There's some more here. It looks like this one's a diode. That's okay, so alright, well that's curious. That's one difference between the two sides as well. Each side has 3 of these ferrite beads, and this one has a diode. So that's one difference. Here it looks like the same number of capacitors, so that looks all the same. Now if you notice something that I thought was kind of interesting, is you notice that down inside here there's some capacitors. That's not generally a good idea to put aluminum electrolytics in the heatsink. Now this is very efficient. We're going to see how warm this gets, but you know, it might be a good idea, since these are through-hole parts. See, there's a capacitor right there. There's the 2 pins right here. Is to take that capacitor out and mount it on this side of the board. Even if you had to lay it down, if you didn't want to. If you stood this board up off the bottom of the box that you install it in, it would be no problem. But you have also the option of laying it down. But you can see on the bottom of the board, there's just a few large parts. I haven't really looked at the parts yet either. I just want to do a quick power up and do kind of a quick check today, and then we'll do a little more investigation on the parts and see what they are. But maybe at this point you can see the copper. This is the input connector right here, and if you notice, these are interesting traces coming down here. There's actually, if you look close, got my fingerprints all over this, but you'll see this big old blue copper plane around here, this big old copper plane. So I can see there's big old copper thing underneath the blue masking connecting these two solder joints, for instance, and that would be the capacitors tied to the capacitors to this pin here. But then you see the silver part is just, it looks like small fine traces, where underneath there's actually big large planes. So what they've done here is they've stripped away the masking to expose some copper. Then when the board was populated with parts and soldered, well, the copper picked up this solder, and that's kind of called tinning. So they exposed these tinned traces for some reason. Not sure why they did that. Maybe somebody has an idea, they can let me know. But other than being able to trace where the circuit goes more easily, you know, so if that's what they're trying to do, expose it for the guy who's going to use this board. I don't know. Now, on this side, I just want to point out again that this says AC 22 volts, ground, AC 22 volts. I think it's interesting they point out the grounds, that they call those terminals grounds, where it's really AC power coming into this. We're going to power this with DC power. I'm going to show you how that's done. Okay, so here, let me focus in on that. There we go. Okay. Well, here, let me move this. We're gonna put DC power into this and watch LEDs come on. Let's do that. And what we want to do is make sure we put the correct polarity on the capacitors. And I'm going to just draw the schematic of the input circuitry so I can show you why we're going to be okay putting a DC power supply on this, okay? All right, so let me draw the circuit, and I'm going to draw the terminal block right here. So I'm going to draw it right here. I got to give myself some room here. And we're going to put the 4 pins in here. There's the terminals, okay? Now this terminal here, it is called AC 22V, AC 22V, and ground, okay? Now so I thought it was interesting, they're grounds. You know, let's just real quickly just prove that those 2 grounds are tied together, so that maybe it's not ground for this one and ground for this one, and they're not really the same ground. Let's just see if they are or not. Okay, 0.05. Or 0.5, I mean, and 0.3, that's funny. Okay, 0.3. So I guess the short is 0.3. All right. Well, now, you know what? While I'm here, let me check the audio input, see if that ground, because sometimes if they're different grounds, you'll name them differently, but they're all GND. Nope, they're all the same. Okay, I'm going to go over to this ground just to prove to myself they're all connected. Okay, so all those things are connected. Okay, let's go back to drawing the circuit real quick here. Okay, so these grounds are connected, and they're going to come out like this. And you know what I'm going to do is I'm just going to draw this over, give myself some space here, and I'm going to draw a capacitor here, and then another capacitor. So I know that these two capacitors are joined in the middle. I could tell that from looking at the board. And one side's going to be plus, one side's going to be minus. We're going to find out which. And I'm sure this will be laid out the same way. So we're going to call this the plus capacitor, and this is the minus. So the minus voltage is going to come in here, plus voltage is going to come in there, and this is ground. Okay. Now, so we need a bridge rectifier. I'm going to draw it right here. And let's see, if this is a plus terminal of the bridge rectifier, it's going to come over here and connect there. And if this is the minus one, it's going to come down here. Let's see, it's going to come across here like this. And boy, I'm not an artist for sure, but okay, there's plus minus, and now the AC terminals are going to, so I'll draw it this way. That's going to come in there. I'm going to join all these things. This one's going to come across here. Okay, that's my bridge rectifier. Now I'm going to draw the diodes in there just to illustrate something. We want both positives to come here, so I'm going to join the arrows here. So that diode is going to go in that direction, and when the AC comes this way, we want the plus to go this way. So I'm going to draw that diode this way. And then I'm going to draw the cathode. That's the cathode. The arrows show which way the current's flowing. Okay, now this is the minus one, so the arrow is going to point away from the minus. Points away. Then I'll draw my cathode. So, you know, this is the anode and this is cathode. Okay, so there we go. Now, what we will eventually do is hook our transformer up to this and power it with the transformer. So let me see. Transformer, there's the iron core, the primary winding. Okay, that's 120 volts coming in, and then coming out we'll have two windings. So let's see, 1, 2. Okay, there's one. This is a 22 volt AC winding. 22 volt AC. Okay, now what we need to know though when we do this is the polarity of things, okay? And there's a dot convention. It's kind of just showing that hey, when this is on the positive side of the waveform, of the AC waveform, then so will this. This will also be on the positive side. And the minus side, you know, when this goes negative, then, you know, so the dot convention just shows that we're going to be in phase, okay? Now, this says to connect to 22 there. I'm sure it connects this way. And this one, yeah, and this one connects this way. And then these guys will join together and come over and connect there. Okay? So that's how it will be wired up. Okay? So what happens when the AC waveform comes in is, let me just draw a current path. We'll have current flow this way, come up here, and then we'll go through this diode. So current's flowing this way, comes to this diode, and then goes to the caps, comes this way. So just to illustrate this, and then comes up, and then it's going to go through this diode, come back to the transformer. So it comes back this way. So there's the loop, and then it goes to the transformer. So that's one convoluted loop. The diodes are just steering diodes. They just steer the power to go to. They steer the power so that you get positive here and minus here. Okay. Now that's when you get one pulse. Okay. Then when the AC waveform comes down, and that doesn't look like a sine wave, I know, but when it comes negative, then what we're going to do is we're going to flow current. So now current's going to go this way. This will become positive down here. And let's see, how do I draw that? I'll draw right here. So it comes across this way, up around here. Okay, so it's flowing this way with that diode. Okay, my current's going this direction. And then it comes through and it goes up this wire up here, and this time it sees that arrow and goes that way, and then comes across here and goes that way. So that turns on the other two diodes. All right, so that gives you the positive cycles hitting this capacitor each time. So what we're going to do is we're going to take a DC power supply and power this instead of the transformer. So to do that, what we end up doing is, let me see if I got another, just turns out I got another pen over here, another color maybe. Probably, okay. So what we're going to do is we're going to replace this transformer with DC power, with two DC voltage rails. My power supply has a tracking output, so I can have output 1 and output 2, and let's just say output 2 is up here, and I'll just draw it as a kind of a battery similar DC supply, and then draw another one down here just as output 1, and then I just connect these two supplies together, and I connect this here to that terminal and this one to that one. So now I have plus here and minus here, and I have a total of it turns out this power supply I have only goes up 20 volts. I have two 20 volt outputs, so I end up with a total of 40 volts. So this guy will go up to a max of 20 volts, so maximum of 40 volts each. And then the center of these, if you think of about two batteries in series, whatever, I reference the center to ground. So I have plus and minus 20. Okay, that's how it works. So now I have DC power, so it's going to, the current's going to flow like this blue one. It's going to follow like this blue, these blue guys. And it's going to just go around this way. And it's going to come around and go to the minus terminal here. So that's the path. Okay, just like the blue, the positive part of the waveform did. And I just won't be using the other side because it's DC. So here's the pro and con. It's easy. The con is that I'm only using two diodes. So all the power is going through two diodes instead of being split between 4. But they're in the same package, so the heat, this thing, I'm confident. We'll look at the data sheet. Right now, we're not going to put a lot of current through it, but we'll look at the data sheet and verify that the diodes in this package can handle the current all by themselves. I'm confident they can, but we'll verify that. Now, just to finish my drawing over here, I'm going to go back to my blue pen. These voltage rails will go to the power amplifier board. Okay, the power here will go off to this module here. Okay, so now this is I obviously just drew one side and the other side's identical. We're going to flip the board over and just ohm things out, and I just want to find out what, I want to get to know this board a little bit, so I want to know what side of the cap. I can't tell. I mean, some capacitors have the stripe down the side. This one I really can't tell, so I don't know. Like the rest of these capacitors have stripes on them, but these aluminum electrolytics don't have them. So, and they are polarized, of course, so they have to be right polarity. And the diodes will take care of that. They'll steer the correct voltages here. So it wouldn't really matter if I flip this over. I could put the minus, I could take these two, the power supply, and flip it over so the plus is down here and the minus is here, and then the green path would steer my current, so I'd still get plus and minus. So either way, I'm safe. I just have to go to the AC, to the outside ACs, and the two center ACs that are tied together are my ground reference. As long as I do that, I'm okay. So I just want to flip this over and find out. Now, I'm going to trace the rectifier, and the positive pin of the rectifier is towards the red capacitor. So I would assume that this terminal here is going to be plus, and this terminal here is going to be minus, because the minus is on this side. It'd be kind of crazy, and maybe I can just look at the copper on the bottom and tell. I can't tell from the top side. Okay, so here I'll zoom in here. Here's the 4 terminals, and you can see these two are equal distance, and then this one's got a wider gap. Here, let's get this over here. Let's ohm this bad boy out and make sure it's all connected the way we think it is. First, I'm going to go to the bridge rectifier, and one's here and one's here, and I see these pins here equal distance, and that one's a little further, so that's the one that was labeled positive. If I go here, I get a short, so it is connected. So that is a plus capacitor, and then this will be that'll be here plus. Whoops, sorry. That'll be the plus capacitor, and then these center ones are the 2 capacitors tied together, and the minus one is the bottom down here. So we'll just ohm it, verify that, and it is. And just to prove that it's not connected to the other one, or, well, let's see, also it's not connected to the grounds in the center. Okay, then we'll come over here, same thing. Now we're just charging up a capacitor and charging up a capacitor again. Okay, now come over to this bridge. Here's the guy's equidistance, and this is the one spaced out further. Okay, plus. So the plus ones are the ones next to the poly caps, and the minus one will be this guy. Yep. Okay, you know what I want to do is I want to put this in diode mode. See, select, and there's a diode. I was trying to turn on the light, but we can't see it with all the overheads here. Now what we should see, if I go an AC terminal, I should see a diode drop. I do. And I should not see any connection here. I don't. It's just charging caps. So I come to this AC, and I should again see the plus going to this guy, and I do. So just another verification. This will come over here, plus, and not connected, not connected. Okay, now I'll switch leads around. Now minus on the AC, no connection, just charging cap, and then here, diode drop. Okay, and on this AC one, just diode drop, and then backward here, diode, and I'll come to this AC guy. So both AC connections send negative that way. So just to show that on the on the schematic here, when I put this here when I put the negative one on one of the ACs, I just come up and I go through this diode here. I go minus to minus, and I go against the diode and come here to the negative. When I put the AC on this one, same thing. I come up here and I go against the diode down here to the negative capacitor lead. And just the opposite with the plus. When I put the plus here, it comes up and it goes with this diode to the plus. And plus here with that diode to the plus. So now I kind of get a better understanding of my board. I have my plus capacitor here, common or ground here, and minus here. Alright, now I know where to solder leads, and I know what to expect when I start monitoring things. But right now I'm going to put some power on this and show you how we can do it DC power now. Okay, so let me get the leads here. Alright, here's my leads. What I did was I labeled these. I put the green one as the common, the ground one, and black is minus, and red is positive. So that's how I kind of did it. And then over here on the power supply, I have the red on output 2, so this goes to output 2 on the red, and then the minus of output 2 goes to the positive output 1, just jumpered, and then is connected here on the green one. And then the minus of output 1 comes over here. Okay, I'm going to put this on DC volts. What I'm going to do is I'm going to turn on the power supply. You'll hear the fan kick on. And then I'm going to put it in series. Okay, it's in series mode. So, and output 2 is the master. I don't know why they named output 2 instead of output 1. It seems opposite to me, but anyway, that's what they did. And then I'm going to current limit it to 0.2 amps. So it's always a good idea to current limit your power supply, so that when you first power something up, you don't see, if there is a problem, you don't have a lot of energy and a lot of power that can damage your circuit. Okay, so I limited it to 0.2 amps because I want enough current to power the housekeeping or whatever it's gonna take to run this. I know this is really efficient, so it doesn't take much power. And then I'm just gonna bring up the power slowly. I like to bring up voltage slowly. I don't like to do the smoke test where I just turn on the voltage and just flip the switch. I don't like that because then I have to pull out soldering iron or repair things. So I like to go slow and easy. So I'm going to, you know what I'm going to do is I'm going to flip this over so we can take measurements. Okay, make sure that's connected. I got these big old jaws here, so I should have a good connection. Alright, sorry about that glare. Let me move this down here, a little less glare maybe. I don't know where that glare is coming from. There we go. I gotta fix that problem. Try to get a little more light on the subject here. Okay, I'm gonna turn on. I don't have a rotary knob. I just have an up and down arrow. So I'm gonna go up 1 volt and turn on the output. Probably heard that click. And so we should have 1 volt here. Well, we should have 2 volts from here to here because there's 2 1-volt outputs. There's 2 volts. Okay, now if we go to our capacitors, and now remember that was up here was the positive lead. So I like to do that and make sure I've got the right voltage on my capacitors, and it's 1.3 because I have that diode drop, and over here I got 1.3 as well. Now there's one capacitor, 0.65, and okay. Well, you know what? I'm going to show you each capacitor because there is slight variation in the diodes or in the capacitors. So they charge at slightly different voltages, if you can see these, just slightly. As I creep up the voltage, they'll probably get a little closer together. And by the way, I'm looking at the current on my meter on the power supply. It has 3 places after the decimal point, and I do not see any current at this point. I'll go up to 4 volts. So now we should see 8 minus 2 diode drops, which is about 0.7. Okay. Now, as current goes up, the voltage drop on diodes increases slightly. So they started off at 0.55 with just the current of the meter, but as we put a little more, you know, and actually I don't see any current flow of the power supply right now, so there's very little current, but probably more than my meter. Okay, I'll go up. Whoops, you know what? Up. I went to 6 volts. And I saw the current jump up to 6 milliamps, so something's happening. Okay, so I have a total of 12 volts, and I'm showing 10.8. 5.4, so I'm dropping about 0.5, you know, 7 or something across each. I'm dropping a little bit of voltage across the diode, so okay. So 6 milliamps at 7 volts, we got 10 milliamps. 8, we have 13. So it's just creeping up slowly, which is a good sign. Okay, I'll go to 10 volts is 24 milliamps. So I should see 20 minus 2 diode drops. And here I should see 1 diode drop. So 0.6, we're up to 0.6 volt drop now. Let's see if they're the same. I'm sliding off. 936, pretty darn close. 937, 942. Using my Astrometer here, it's an inexpensive, cheap meter. Got a whole bunch of meters, but this guy just has a big display. I should prop that up to take the glare off. I hope that helps. I'm going to creep up the voltage here. Okay, 11. And I like having the capacitors and everything on the other side of the board when I do this, because if something did go, it's not blowing up in my face. Okay, I don't see the current. Okay, I'm at 12 volts, 45 milliamps, 13, 15. So I'm just seeing the current just creep up. I'm going to go up to 20, the maximum of this power supply. Okay, at 20 volts, I have 89 milliamps. So not a lot of current. 19.37, 19.3, 19.31. 19.40. So across here I've got a total of 38.71, 38.68. Slight difference. Another thing that'll happen is once, you know, the diodes have a little time to warm up with current flowing through them, they'll also increase in voltage drop a little bit. So I'm going to turn off the power. Actually, I'm going to bring the voltage down nice and all the way down to 0. Okay, now I'm going to turn off the output. I'm going to flip it over. Now the capacitors, let's see if they're draining quickly. Yeah, see them draining. So there's some, you know, they could have some resistors across them to help them drain. It's a safe thing, so when you grab the board you don't get bit. So it's, you know, you can just kind of see it. So I'll just be careful and grab it by the edges. But I'm going to flip it over. Alright. And let's see if we can watch the LEDs turn on. When we see the current flow, that gives us a good idea that at some point we're going to see LEDs. Okay, there's the power supply, the output's turned on. 1 volt, 2 volt, 3. It was 6 volts, I think, where I saw. Well, at 5 volts now I see 2 milliamps. I don't see the LEDs. 7 volts. There might be just the slightest bit of glow down there. Yeah, 8, 9, they're definitely starting to glow. I don't know if you can see that, but they're definitely on. I'll turn off the light here. So I think you can probably see them now. So they are glowing, and I'm at 10 volts, so I'll just go up to 20, see how bright they get. I'm curious if the red one turns off at some point. Nope. I'm actually at 21 volts. My power supply let me go 21. So, but you know, both LEDs are on. I don't know if that's the right thing or not. Alright, well, this video is getting kind of long. I just wanted to kind of get us to know the circuit a little bit. We'll get to know a little bit better. I'm going to put a signal in here and see something come out. The relays will turn on. So next time we'll get this guy be a little bit more exciting, I think. Now, just one thing I want to show you though that I'm going to do next time is let's turn on the light. There's a little board that came with this. This little board here. Let me get up close so you can see it. I'll zoom in a little bit here. So this little board came with this guy. And it's interesting. This says right, left, ground in the middle. And over here, right, left, ground B. Oh, sorry. Yeah, this is ground A. And this side says ground B. You can see that. So they're just two little isolation transformers. So without documentation, I'm only just guessing, but I think it's a pretty good guess that this guy, this isolation transformer, okay, this isolation transformer is wired like this. There's two transformers, and there's the left side and the right side, and then there's ground B and ground A. So one of these inputs and one of these inputs gets wired to the output, and then you put your signal, your left and right signal here, and then you get isolation from your whatever your signal is coming from. So we're going to do some phasing and some turn ratio on this, and I'm going to see how linear this is over the audio spectrum too. So we're going to turn on the scope and put a signal generator in this and see how well this works, and then we'll hook it up to the amplifier and watch the amplifier run. I have a THD meter. We'll take some total harmonic distortion measurements across frequency, across the spectrum. We'll take a number of frequencies. If anybody has ideas or things they want me to try, just let me know down in the comments. And if you like this and you want to see more, give me a thumbs up, and I appreciate you watching. Thank you.